Hey everybody, it's Miss Bell here from the Science Lab, and I am going to talk to you guys today about Earth. Now, we're not going to be talking about the outside of Earth, like the oceans and the continents. No. Instead, we're going to be digging deep, inside Earth's layers, and we're going to talk about those distinct layers going from the core to the very outside layer. They're all unique. They all have their own set of characteristics of what makes them what and why they are where they are. But before we get started, I want you to think about certain things or items or foods that you know of, that you've seen, that you've used, that have their own set of layers. When I cook, I like to use onions. When you cut into an onion, you can see those distinct layers. Or when I pick up a piece of fruit, an apple or an orange, I can cut into that fruit and I can see layers as well. I can see the outside peel, like the rind. I can see that juicy fruit inside. And then sometimes you can see seeds from the very center or core of that piece of fruit. And just like an apple, an orange, an onion, our planet is just the same. There's layers going from the outside to the very center. So let's get to it. Let's start learning about Earth's layers. Alrighty, so here we have our planet Earth divided by the equator, north hemisphere, south hemisphere, and I'm going to turn our planet into Pac-Man, waka, so that we can see inside Earth's core, in its layers. And as you can see from my drawing over here, the left side, I have designed it to where we see those three main layers. And then on the right side, we see those three main layers kind of be broken even further into subcategories. So when we talk about the crust, my blue layer over here, we know that is the outermost layer of the planet. It consists of our oceans and our continents. So by that matter of fact, we know that that is where we live. We live on the crust, the outer part of the planet. And you can see by my percentages right here, 16% for the core, 83% for the mantle, and 1% for the crust. That is the thinnest layer of all three of the major layers of Earth. It's so thin. It consists of silicon, oxygen, and aluminum. And when you talk about oxygen and silicon, then we mention the word silicates. Those are just minerals rich in the elements of oxygen and silicon. And when you talk about the layers of Earth, there are 4 things you need to keep in mind. Composition, what is it made out of? Temperature, how hot is it depending on where you're at? Pressure, the inner layers are going to have so much more pressure because look at all this weight from everything sitting above it. And state of matter, solid, liquid, gas. So because the crust is the very outside layer of our Earth, we know that is less dense, kind of like a swimming pool. If you throw a floaty in there, it's going to float. It's less dense than the water, so kind of like our crust. It is less dense than the mantle and the core. Now when you talk about the mantle, this huge chunk right here, this 83% out of all the layers, that is the majority of the inner guts of Earth. And it also contains silicates. Now the mantle can kind of be broken into the upper mantle and the lower mantle. So upper and lower, and each of these upper and lower portions of the mantle, they have different densities and a different plasticity. That's a hard word to pronounce, but it's easy enough to understand. So when you talk about plasticity, basically that's just a solid that kind of moves and grooves like a liquid. It can flow, it can be flexible, it can stretch. Think of silly putty, or think of like homemade bread dough. When you knead it, it's thick, soft, gooey, solid, but you can stretch it, you can form it, you can poke it. Now the lower mantle, that is a solid layer right there. But the upper mantle, this chunk right here that kind of looks like it consists of 3 layers, that is a semi-molten state. And when we talk about molten, that's like a solid that flows. So think of a volcano. All of that magma deep in Earth's kind of like the core, and it gets hot, 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 and it overflows, and that magma is molten lava. It turns into molten lava. It's a solid, but it flows almost similar to like a thick liquid. Now the upper mantle right here, this is the cause of the crustal plates, like the oceanic crust and the continental crust, causes them to move because of it having plasticity. So because it's not a solid, it's not stiff, it's not holding still, it has plasticity, so it's moving, which makes the things above it kind of move as well. And the upper parts of the upper mantle, so the top part of the upper mantle, that would be considered part of the lithosphere. Now the lithosphere, that consists of all of the outer crust, so the oceanic crust and the continental crust, and only parts of the upper mantle. And the word lithosphere has a small portion of it, lith, L-I-T-H, and that's a Greek word, and it means stone. So the lithosphere itself is kind of like a strong rock layer. It's very rigid. It's not going anywhere. But the layer underneath it, which we'll talk about in just a moment, that's not a solid layer. So the lithosphere layer itself is a solid. Now the layer that lies underneath the lithosphere, we call that the asthenosphere. A little bit trickier to say.
Asthenosphere.
And that has some very cool characteristics for that layer of Earth. Again, it's a solid, but it flows. So the asthenosphere is kind of this medium, thin, very thin layer, orange right here. And that's flowing, so everything on top of it can kind of shift around, and you'll learn about that when you learn about plate tectonics. Again, the word asthenosphere has a chunk of that word, astheno, and that's a Greek word, and so that kind of means weak, or not strong, or like lacking strength. So even though the lithosphere is a solid, sturdy, the asthenosphere that lies right underneath it, that's more weak because it's flowing and it's moving around. Now, when we get to the very, very center of Earth, that is going to be where you find the highest temperatures. Extremely, extremely high temperatures in Earth's core. And our core is made out of iron and nickel. So even though we said that The other two layers have silicates, with silicon and oxygen. There's none of that in the core because iron and nickel are heavy and dense compared to those. So the core of our Earth is the densest part of all of Earth's layers. Oops. And our core can kind of be divided into like two sections as well. We have the outer core, which is this kind of like this light red, and the inner core. So the outer core, that's mostly molten liquid, and the inner core, that's a hard, solid. And the reason, because it's a hard, solid, has to do with its density. So not only is the inner core the hottest layer of all the layers inside Earth, it has a ton of pressure because of everything that's sitting on top of it. So pressure, weight, pressure, that is what made it into the solid core that it has become today. And the inner core, because it's a solid of iron and nickel, that is what helps us generate our magnetic force around our planet. That's how we have gravity. Everything is coming into the core. That's why our moon revolves around our planet, because of gravity, because of those gravitational forces, because of the core of our planet. But if anything, remember we have three main layers: the outer crust, the inside mantle, and the inside the very core, the core. And those three layers are where they are at as of today because of four different reasons. We have temperature, we have pressure, we have state of matter, and we have composition. So Earth is just so cool, not only on the outside as far as geographical features and what we're able to see with our eye, but it's so cool because of all the layers inside that we can't see. But science has brought us to know all of this knowledge, and I like learning about Earth. I like learning about something no one has ever seen before. It's cool to me. Hope you guys liked it. Bye, guys.